Welcome to day 15 of Advent of Code 2023. Let's go see the puzzle and my solution around that. In part 1 we have a set of strings, something like this that we have here, and they are comma separated as you can see here, and each part of this string should be converted to a hash value, and the hash value is working like this. We start at 0, we get the ASCII code of each character, add it to the value that we already have, multiply it by 17 and then divide it by 256 and get the remainder. And we will do that for all the characters in a substring of that string and then add those values together. So for example, for rn equals 1, the value becomes 30. For this one, 253, and we add them all together. And this is the final result for the part 1. So let's go and see the code around that. For part 1, it's pretty straightforward. We get the data, which is the input. We split it by comma to get each part of that string, and then map it to a hash. So mapping works like this, the same thing as described. We split it to get an array of the characters, and for each character we get the ASCII code, multiply by 17, get the remainder of dividing by 256, and then return it in the end. And when these hashes are converted to this, we can just reduce them to a final result and then return the value. On part 2, however, it gets a little bit more interesting. They say that we have a number of boxes labeled from 0 to 155, respective to the values that we get from the hash values on part 1. Each of these boxes has a number of lenses, and we can insert lenses inside them. And the lenses have a focal length that is ranging from 1 to 9. Those values that we had was kinda instructions. And the instructions work like this. In each step, we begin with a sequence of letters that indicate the label of the lens. So, for example, this means that this is the label of the lens that we need to use. And then the label will be immediately followed by a character that indicates the operation we need to perform. It's either this or this, equal sign or a dash. If it's a dash, we need to go to the relevant box, and the relevant box is the conversion of that substring into the hash. So for example, if we have this, we get the rn converted to 30, and we need to go to the box number 30 or box index 30. Then we need to remove that lens if it's there and move any remaining lens as far forward in the box as they can go. So it's like an array, and we need to remove the item at index x. And if the operation is a equal sign, we will have a focal length value after the equal sign and go to the box. If there is already a lens, we remove that lens and replace the new one. If there is not a lens, we need to put the lens in the end of the box. So for example, here it says that when we have this, the box at index 0 will get the rn with the value of 1, and so forth and so on. Gets interesting here. This means go to box 3 based on the hash. We go to box 3, we find the OT, we have OT 9 beforehand, and now we need to have the OT 7. So we remove this and add the OT 7 here and go forward. And in the end, we need to calculate the values that we have for each of the boxes using this formula that is provided here. So let's go and see the code. For part 2, the converting to hash is the same thing, so we don't cover it anymore. We split it the same way and we get the commands this time. I label it command so that we know that each part is a command. And in the beginning we have boxes that are all empty, so we provide the new array of 256 and then map to a new empty array. Then for each of the commands, either it ends with a dash, make it a bigger, or it ends with a equal sign. If it ends with a dash, we remove the last character, which is a dash, and then get the label. So this is the label that we have. Now we convert that label to hash using the formula that we have in part 1. And then we go to the box at index hash and we remove that lens if it's there. So we use this filter, and this filter works like this. If this value is there, it will be removed using this unequal comparison, and if it's not there, nothing would happen. The array would be the same, so to say. Otherwise, the command has a equal sign. If it has an equal sign, there will be a number of characters after that that will show the lens focal length. So we get those values by splitting this based on equal signs, get the label part and get the f part. So this will give us the f that we want. We go to the hash, we get the hash based on the converting the label to the hash, and the index that we need to insert the lens into. So we look into the box at that index. We are searching for a lens that has the label as the label that we have just found here, this label. If we didn't find it, then it's fine. We just push the new lens with the label and the focal length that we get from here into the box at that index. Otherwise, we go into that box and in that index and change the focal length to the focal length that we get here. Then in the end, we get a number of boxes, and within each box there is a number of lenses, and each lens will have a focal length. So we map the boxes to a box and we get the index of the box because we are kind of needed here. And for each of those boxes, we again map that box based on the lenses that it has, and each lens will have a lens index. And we perform this formula, which is the thing that is described here. 1 plus the box number of the lens, then the slot number of the lens, which is the index, and we need to add 1 to it, 1 for the first lens and 2 for the second and so on, and the focal length of that lens, which we have here. So we multiply all of this together for each of the boxes. Then each box will have a number of values. So each box will be something like 2, 3, and like for example 100. Then we flat them so that instead of having a 2D array, we have a one-dimensional array, and then reduce it by adding all the values together. And that perfectly works. So yeah, nothing so special about this puzzle. Pretty straightforward. And I hope you have enjoyed the video. If that's the case, please provide a like, comment, or even subscribe to my channel. And see you in the next video.